Hello friends, welcome back to my channel Tech 360 Degree Cafe. Today I will cover conditional looping in Python, which is one of the important programming constructs of Python, and I will be covering if, for, while, break, and continue. And a lot of constructs and programming logic can be implemented through these conditional loops. Apart from that, these loops can be used for implementing complex business logic and also uh, mathematical constructs, concepts like Fibonacci series, multiplication tables, and simple to complex rules. So, without wasting any time, let's get started. So, we have this screen of Google Colab, which I referred to in my previous video. So, I will share that video link here so that just in case you want to have a look at how we can start on Google Colab. So first of all, let's start with the uh, for loop. So I have written the statements here. We will just copy and execute. So the first construct is a simple for loop where we traverse a range. So the statement reads for range underscore span in range 15. We print the range span. So let's execute it. You can see it prints the numbers from 0 to 14. So that means it's if we give the range n, so it will print from 0 to n minus 1. So within that number, now it excludes the n. So if I give 25 here, it would print from 0 to 24. And later on, I would also cover more about range and other things. Then you can see like it can have a starting point and a gap also. So that's enough for now. It's just a simple example. So let's move to the next one where I would be capturing a simple if else statement. Let's execute, copy and execute it. So you can see it's a we have two numbers and we are doing certain operation on these two numbers, and based on the result of the execution of the operator, we will print out the content. So let's execute it. Okay, so here was the logic. We assigned a value to number a to the variable a, and another value to the variable b, and then we took a product of a and b. The condition was that if it's greater than 900, then we print a certain command, and else we print another command. So in this case, since it was less than or equal to 900, so the result is accepted. Let's tweak it a bit. Okay, let me give 10 here and 90. So now if we multiply a into b, so it would be 900, and the condition is greater than 900. So let's check what result it gives. You might have guessed it, like what it would give, but let's execute it. Okay, so here again you get the result as accepted. It's greater than 900. So another way to test it, either we give greater than equal to 900, and you can see the result has changed. Why? Because we have given the condition as greater than or equal to 900. So if any of these is satisfied, we get the above message out of bound. Now let's tweak it a bit. If I make it 93 and I would remove the equal sign here, So the result would be the upper statement. So this way you can put other conditions. You can even have more variables like C, D, E. You can have other logics like where you are adding a few numbers, then subtracting them, then maybe even division, or you can have a very complex kind of statement. And yeah, later on you would see me we can even implement it in functions or using multiple other statements like use of while or for. But as of now, uh, this is the simplest that we can cover. Sorry, I have a bad cough today. Oh, sorry guys, slightly bad cough and cold today and slight fever also. Anyways, let's move to the next part. So next up is if, elif and else. Apart from the if and else, which is the simplest case, we could have multiple conditions. So we can also have multiple ifs, or another case could be that we have if, elif, and else. So elif is like the second ifs condition where you have passed the first condition and then you want to have a even more detailed check. And if these two checks don't work, then the last condition would be satisfied. So in this simple program, I have two variables which are assigned certain value. Based on those values, we have certain checks. If the first check is satisfied, then we print certain message. For the second statement, second condition, we have elif. So if the if condition is not matched, then we move to elif. If elif also fails to satisfy, then we have the else statement. And maybe we can try it out later. I think we can have multiple ifs or nested ifs, or I think elif can be repeated, but we need to see. So as of now, I will just uh, run these. Maybe in another session, or you can say another video, I would cover those minuter details. Let's execute this one. So we have the numbers 20 and 9, and when we add them, so 20 plus 9 makes 29. And then since it's less than 100, so the result is lesser than expected. Now let's tweak it a bit and make it 94. So what would be the result? Let's write it down here in the comment section. Z would be 20 plus 94 is equal to 114. Just simple arithmetic. And let's see what condition it satisfies now. So you can see it moves to the second condition. Why? Because 20 plus 94 is 114 and it's not less than 100. It's greater than 100. So it would skip this condition and it would jump to the elif condition. Now elif states that elif z, that is the result of adding those two numbers, it is less than 500. So it will print a statement still not found. So if you want to check it further, let's try something more. Let me keep it 112. Now, what do you think would happen? Let's see. Okay, so since the result is greater than 114, it does not satisfy the elif condition and it prints met target, which is the else condition. And in other ways, we can maybe keep the earlier condition and see the results with altered numbers. And we can see the result is met target. This way we can make changes and we can do checks for other conditions. And not only the numeric ones, even for the strings, we can have these kind of checks, maybe the compare string comparisons or figuring out certain lengths and so on. There could be numerous cases. The fourth example for today is a random reducing value example. Not a very good example, you might say, but going by the same principle, we can even have uh, recurring some kind of recurring formulas, or we can even compute loan amortization schedule where you have those reducing balances with differing principals and interest. Okay, so let's have run this one. We have a counter which starts with 125, and then we make a check that if it's greater than equal to 50, then we go on reducing the counter. So let's run this one. Okay, so okay, this printed statement reduce value keeps on repeating. We it is not essential, but I just kept it for the example. So it starts with 125, 120, and goes on till 50. It stops. And there is another way where which we can use, and let's see. This is one of the way in which we can keep it. Okay. So see the instead of writing counter 1 is equal to counter 1 minus 5, we can simply say counter 1 minus is equal to 5. Just make sure that minus and equal to are nearby, and similarly you can do for plus and equal to. But if we make some change, let's see what happens. Okay, we get an error. It says invalid syntax, and the reason is simple. We made a space between it, and similarly you can have a increasing series where you start with a smaller number and you can make a check of less than equal to or less than, and then you do a progression in the increasing order. So instead of minus, that would be plus, and you can even have a try with multiplication or division for other kind of series or number, and you can write other logic also. So my next example is something which I enjoy doing. In fact, it's a multiplication table, so something that can take you to your childhood memories, or it's we need them otherwise also, even if we are quite grown up. So anyways, so uh, here is the key. We have a number for which we need a multiplication table to be printed, and we have an initial value which is the 1. So every multiplication table starts with 1, and we have a max counter. So suppose we only need till 20, and we can put anything here. We can have 30, 40, 50, or even bigger numbers. As normally we do not require more than maybe 20, 30, or 50, but it could be a need, it could vary. And then we print the values. So we print something, and then we have the while loop. So while this value, the multiplier value, is less than equal to max counter, which is 20 here. So it will print the table, and here again we have is equal to and plus 1. So we can replace it with plus equal to 1, but let's first execute this one, then we will make the changes. Okay, so we can see a table of 17 till 20. So these can be changed also. Here 17, 34, 50, and 68, and going till 340. Now we can make a change. If we need some other number, maybe I would go for 19, and instead of 20, let's go for 30. Let's execute this one. So you can see it starts with 19, goes till 38, 57, 76, all the way to 570, which is 19 into 30. And we have another way of writing it, which is less cluttered. So we just say multiple val plus equal to 1. So it will be incremented by 1 each time till it reaches 30. And the result would be the same. So always remember minus is equal to, which is decreasing the number by a certain value, or plus is equal to. For both you have to keep the that sign of minus or plus together with is equal to. If there is a space, it will give an error. So next up we have the break statement. And one thing more, if we need to clear the output, we just click here and it's cleared. For okay, so we have you have came to know about if, for, and while loops, and the kind of checks and the executions that we can have. Apart from that, we have a break statement. So what does break statement do? It goes through a pattern, and whenever it finds a match, it will just stop there. Or you can say it will break the execution of statement. Uh, how it does? Let's see. So we have a string, which is string 1, and we have a check that if this value val underscore check, its value is I, so it would break. That means the execution would stop. And this is needed just in case we need to find a pattern within a string or a list of values. So once that value is reached, we need to print that out, or we need to get that out. It's also useful in certain data structures like stacks, queues, where we need to stop the execution after finding out something, or maybe it's kind of a dictionary implementation. In simple terms, we will just execute this program. So you can see what happened. The this variable, it started from s, then it traversed to t, r. Once it matched I, so I is the fourth value here within this string. So it break. So break means it discontinued, and then it came out of the construct. Okay. So continuing from that, we have the continue statement. So now we have the continue statement. Uh, it's kind, you can say it's opposite to break. So if we have a construct where we need to find out certain pattern, maybe it's a character, number, or some other kind of value that we have in maybe in some data structure. So once that is found, what we need to do, we need to jump over it. So we skip that one and then we continue. So uh, it could have been maybe it could have been a good idea to keep this statement as skip and continue, but maybe that wouldn't have sounded nice. So they kept the continue word on. Now let's execute this one. Let's see what happened. We have rapid encodes as the string that is passed. So we traverse through R, A, P, I, D. Then we check that we have the capital N here after rapid. So what it does? It skips capital N, then it prints whatever is there outside the, sorry, after the capital N. And we can see it prints everything, and then once this execution is over, we get the statement now outside the loop. So you can see the indentation is very vital here. After the for loop, there is one indent here with if. Then we have another intent for continue. That means it is the inner statement. Then this one is matching with if, and this one is the last one. So these are some of the fine points that we have to consider with these statements. And the good part is that if we miss out something, Google Colab or in fact other ID tools also, they instantly give us the warning messages. Like suppose if I keep it here, let's see what happens. See, we already see a red mark, so it will likely be an error. It's just taking time. So and the error message is quite clear that the indentation does not match with the outer indentation level. So what it means that we need to follow the indentation. Just crisp and short, and once I do it, everything is in order. So that's all for today. I hope you like this basic overview of the conditional looping. Uh, Maybe you can share in the comments that whether you would like more such examples, and I am in two minds whether to have another session on these conditional statements. Maybe I will be here with more finer examples, or maybe we can have another topic. Anyways, let me decide that. As of now, that's all for today. Thank you for watching. Do share, subscribe, like, and comment. And if you like to have more practice on these Python statements, you can always use Google Colab as a starting tool. And we even have the Python ID that you can use. Bye for now. Have a nice day. Thank you.